Wodonga's 20-piston filler was supplied as a total freestanding unit from the Packaging Research Corporation. PRC are located in the United States of America at Denver, Colorado. The PRC filler was supplied with transparent hinged upper guards and drop-in stainless steel panels to cover in the bottom gear drives. The guards can quickly be lifted out and set to one side, providing good access. The transparent guards can easily be opened to allow quick access. The guards can be removed completely for total access during major work. To provide unobstructed vision, the top guards have been removed for the duration of this film only. The PRC filler has three significant features which are different to the TEG and PF fillers at Uncle Ben's of Australia Wodonga plant. The first point of difference is our existing TEG and PF40 and PF34 fillers have a central filler bowl which holds product that is then gravity filled into the filler pistons. The PRC filler has no filler bowl but uses an in-feed spout that is sealed from the atmosphere. Product is pressure fed into the in-feed spout by a pump. It was found necessary to use a very specialised pump that would not damage our delicate fish chunks in gravy product. To achieve this, we use a 519 Marlin Research Corp piston pump which provides product at continuous flow with constant pressure. The product is pushed in turn by the pump pistons through the flap valve along the pipe to the filler. The flexible hose section is supplied by PRC and is used to minimise vibrations and misalignment forces disrupting the fill chamber. The fill chamber replaces the filler bowl as used on our other existing fillers. This chamber is held up by an airbag which allows for quick and easy installation and adjustment. To remove the fill chamber, the air is isolated, collapsing the airbag, allowing the in-feed spout to be removed for inspection. It's important not to have excessive air pressure as this will make the fill chamber act as a disc brake on the rotating cavity plate, leading to excessive drive horsepower requirements. The low-profile spout has a very shallow fill chamber, allowing the cavity plate to be lowered to suit our handy can, which is 62.5 millimetres high. The filler chamber has a gasket and keeper plate which are held in place with dowels. The cut-off edge is a single stationary block which can quickly and easily be changed during a production run. Note that the cut-off block is the low-profile spout is rectangular and can provide 4 cut-off edges before it needs to be replaced. The high-profile spout, which provides a gentler product approach, comes supplied with a curved cut-off knife. This knife can only be rotated twice before replacement is necessary. The knife on the right-hand edge of the in-feed spout is the wipe-off knife, which cleans the bottom of the pistons. With this design of having product fed under pressure, the filler pistons can only be filled with positive product pressure and confirmed can supply. The no-can, no-fill system uses a sensor to detect cans at the in-feed worm. The plunger solenoid pushes the locking pins in, preventing the pistons from being filled. On each revolution, the locking pin is retracted after the fill chamber has been cleared by the piston. As cans are introduced to the filler, the no-can, no-fill unit releases the appropriate pistons by not engaging this piston locking pin. This allows the product pressure to push the piston up. The pistons follow the restraining cam up to the adjustable pad. By rotating the handle, the operator can alter the fill weight to the desired figure. When the piston moves beyond the adjustable pad, the air cylinders push the filled piston up onto the next pad, which is stepped up. This induces a vacuum in the piston, holding the product up. We'll now take a look at the piston construction. Shown is a complete assembly with its air cylinder damper. The function of the cylinder damper will be explained shortly. Removing the piston from the stainless steel liner reveals the piston makeup. The piston is smaller than the diameter of the can to be filled. The piston is made up of 1. The cam follower rollers, and the reason why one roller is offset is very important and is covered later. 2. The centre mount has a key that prevents the piston rotating. 3. This is the piston shaft with the keyway. 4. The upper piston ring acts as a guide and wearing and is located by a circlip. 5. The standard O-ring provides the piston seal. 6. The lower piston head is made of a hardware-resistant material. 7. Is the locking pin that no can, no fill plunger solenoid pushes in when no cans are detected, so locking the piston in place. The air cylinder was originally supplied to act as a shock absorber to smooth out the piston movement. The piston sleeve is made of 3/16 stainless steel and has a locating dowel hole ensuring the piston and sleeve are correctly assembled. There are 2 holes in the sleeve to prevent the cylinder being pressured during operation. When the piston O-rings fail, product gravy leaks out of this part. The notched groove locates the piston sleeve in the cavity plate during installation. The O-ring seals off the piston sleeve and cavity plate during the fill cycle. We now come to the second major feature of the PRC filler over our existing fillers. The PRC design allows the inlet port to be as large as the piston. Inlet and outlet are the same, minimising the amount the product is worked. This feature allows very large chunky products to be processed with minimum product degradation. These advantages are very obvious when inspecting a typical PF piston, where product gravity feeds into the inlet as the piston withdraws. The inner sleeve rotates. Product is forced out of the small outlet port as the piston moves in. The third feature of this filler is the ability to adjust the piston penetration into the can. This option allows stiff mixers to be pushed down into the can to ensure there are no problems with fitting the lid on the can. The maximum penetration achieved on this machine is 8 mm. Varying the penetration from 8 mm back to 0 is done by quickly adjusting the empty stroke restraining cam. The secret to the success of this option was to pressurise the piston damper cylinders, which originally were the shock absorbers with a constant air supply. This has been achieved by having air supplied through a rotating coupling down the centre of the main filler shaft. The air is distributed to all the air cylinders via a manifold locked onto the main shaft. Air is run via the plastic hoses to each air cylinder, providing a positive upward push on all the pistons. The upward force means the pistons follow the cam profile at all times. This ensures the piston retracts up into the cavity plate before passing over the in-feed spout. Should the air fail, the safety uplift cam will lift the piston up by contracting the outer piston roller, as pointed out on the bench. The filler, as supplied, had a major can handling problem, which occurred at the centre star wheel transfer to the outfeed worm. The original outfeed worm began where the star wheel lost control of the can. This meant if the can was not exactly in position, the worm would miss the can and a major can jam resulted. The worm was replaced with a longer lead section to ensure can transfer did occur. Other improvements at the same time meant replacing our high-profile inlet spout with a low-profile unit to allow a standard centre turret star wheel to replace the existing short finger star wheel. This dramatically improved small can handling, as the longer finger could clear the low-profile spout and give the can better location control. A second major concern to date with the machine has been an out-of-timing problem. The filler exhibited excessive movement from backlash. This was due to the centre shaft locating key having some movement. To improve the situation, the key lock has been replaced with a taper lock, which securely locks the cavity plate to the centre shaft. During operating conditions, the empty can supply is gravity fed into the in-feed worm onto the in-feed star turret. The can then passes over a lift-up cam, which lifts the can up onto the filler guide rails once the can has cleared the in-feed spout. The can is held by the centre star turret relation to the filler ports. The filled cans are locked onto the outfeed worm, and then the transfer chain accelerates the cans into the larger pitch infeed chain on the closer. Our closer is a 12P Goitz 6-head unit, which is similar to a 60L Angelus closer. The filler is presently used to fill our 3 chunky dined fish products, which are our high-quality premium canned cat food. The filler is currently under evaluation to fill standard product when not in use on dined fish. The filler operates between 300 to 600 cans per minute. This speed range allows full utilisation of our hydro chains. The next few months of operation will be monitored to allow long-term decisions to be made on the PRC design's future at Uncle Ben's of Australia.